Now, briefly, these are the permittivity of the electric and magnetic constants are not universal constants. They have to do with the electrical fields that are in anything. For instance, a diamond, where these are very strong, that decreases the speed of light. In a diamond, light travels at half the speed that it does in the air. And that's when you cut it right, that's why it's got fire. The light goes in and comes right back out at you. Okay? So if your fields are very strong, your speed of light's low. If these are weak, they're on the denominator here, on the bottom. If they approach zero, what happens? Speed of light goes through the ceiling. Okay? This is what it looks like. It's traveling this way, direction light. You got electric field, whoop, in red, whoop, going up and down. In sync with it is the blue field, which is your magnetic field. That's what it looks like, light. But it's traveling very fast and a lot of frequencies, up and down. The question is, does the light speed, which he fixed at here on the surface of the earth, it's 3 times 10 to the 8th meters per second. That's 186,000 miles a second. It's the second postulate of Einstein's 1905 special relativity. It's the main principal deal of special relativity. It has been a difficulty for biblical believers in a young earth and a young universe. The reason is, if it takes 20 billion years traveling at Einstein's speed from distant galaxies to travel to the earth at the speed enshrined by Einstein's relativity, then that light had to be emitted or given off by those galaxies 20 billion years ago, or it had to be created by God in transit. Okay? If that's the case, then you can't. The universe is 20 billion years old. Possibly. Einstein's special relativity would eliminate a credible young Earth possibility. However, since Maxwell's 1800s or 1860 derivation of this, C equals 1 over these constants, is true, and since the electromagnetic fields become very weak in deep space, far from this, they come from, these constants come from the charges that are in matter. So as you move away from a celestial system like the Earth or the sun, these become very weak in deep space. So what happens? That approaches zero on the bottom, and the speed of light does what? It approaches infinity in deep space. Then the speed of light in deep space will approach nearly infinite speeds. By the way, we have proofs of this thing. It's called the Pioneer anomaly. We sent probes out ahead of the Pioneers back in the 70s, and they kept track of them. Pioneer 10 and 11, they lost track early. Pioneer 10, we kept track of it until about 5 years ago, and it was 3 times the radius of Pluto. Pluto's out there about, 4 billion miles, okay? These are out about 12 billion miles. We send a signal out to them, and it takes about 7 hours and comes back. Only it's traveling faster. So we know where the probe is, but the signal indicates that it's closer to us. And each time it got worse. The further out it got, the more discrepancy we got. Why? Because the signal traveled faster than Einstein's speed. And if it had gone out further, it would have just been really booking it by the time you get in deep space. It only takes 2.5 hours to clear Pluto. And your fields become very weak after that, and man, it goes right through the ceiling. In contrast to that, they shot probes, a guy named Shapiro, in the 60s. He bounced X-rays, which are the travel speed of light, off of Mercury and of Venus. And what happened? It slowed down because you're getting closer to the center of the charge of the solar system. It's more dense. Even though it's space, the fields are denser. And this stuff slowed down, just like Maxwell predicts. Let's give you an example. The light from Polaris, that's the North Star, then may have been emitted from the star only hours ago, instead of more than 50 years as commonly held. They say it's 50 to 70 light years away. That means it took light that long to travel here. But if Maxwell's correct, it probably only takes hours to get here. Now, when it leaves there, it's speeding up. It comes through space nearly infinite speeds and then slows down as it approaches our solar system with the electric fields and electrons and protons. The light from distant galaxies may be only years old instead of tens of billions of years as commonly held. Because it doesn't take there's hardly any fields out there to go through. And so it's really booking it. The interesting thing about this is, you remember Star Trek? The warp speed? That's where you're going multiples of the speed of light. Well, that's not possible according to Einstein. But if Maxwell's correct, who was before Einstein, matter can travel up to the speed of light. It can't go faster. Well, if the speed of light goes up, then matter can travel that way. If you get a propulsion unit, you could visit the most distant galaxies in a lifetime. If you had the right propulsion system, and Maxwell's right. The speed of light is not constant, especially in deep space. Maxwell's derivation of the speed of light, contrary to Einstein's special relativity, means that the speed of light will approach nearly infinite speeds in the weak electromagnetic fields of deep space, far from celestial systems composed of subatomic electric particles. And everything's made out of those. You look at periodic chart. 1 electron, 1 proton for hydrogen. Helium, 2 electrons, 2 protons. Lithium, 3 electrons, 3 protons. Everything's made out of electrons and protons, electric charges. And those don't change at any speed, by the way. There's no relativistic change of this. So as it gets away from these systems made out of it, those constants go down and the speed of light goes up. There's no place that it's zero, electromagnetic fields. There's no place, because these are infinite fields. But they're very, very weak, and the speed of light goes right through the ceiling. Observation. Adam and Eve could have seen many of the 7,000 visible stars in today's sky. That's what you can see with your eyes. On the 6th day of creation. And we can see the most distant galaxies today with our most powerful telescopes less than 7,000 years after the creation. We don't have to wait 20 billion years for the light to get here. Light from the distant galaxies, this is a deep field shot. They cranked up the Hubble as strong as it could get, aimed it up perpendicular to our galaxy, or the Milky Way galaxy, to shoot out into deep space. They still got 1 star out of our galaxy. These are all galaxies out there. Those aren't stars. And what happens? They're disappearing into distance, smaller and smaller, and you're looking into infinity. There's no end to them. So what do we have coming from them? Even with a Big Bang, you can't blow them out there at the speed of light and send a signal back to us in 20 billion years. Even if they're traveling at the speed of light, and they're not. You think we have a problem? Big Bang has all kinds of problems. So what you have, is this light new or is it ancient coming from them? Is it Maxwell or is it Einstein? Is it a new universe or an old one? Let's sum up the first law that we have of modern science. Matter and energy originated out of nothing during the creation events recorded in Genesis 1. It didn't come out of a black hole out of nothing with no agent. It took an agent to create it, and it's not a natural agent. We'll get into that later. The first law of science, the conservation of matter and energy, began after the 6th day of creation. Not 1 gram of matter, as we mentioned, or joule of energy has been created or destroyed since the 6th day, except in miracles. The first law of science is the basis of most of the laws of science, or your ideal or conservation laws. The order of matter and energy in the universe originated during the creation events recorded in Genesis 2. God then maintained a perfect universe in perpetual motion without decay and corruption during Genesis 1 and 2. We don't know how he did that, because that's not the normal state of things. They decay. But you remember Moses when he saw the burning bush? Was it consumed? No. But as he approached the thing, this voice came out and said, "Take off your shoes. You're standing on holy ground." God was in the midst of that thing, and he kept it from burning out. God, in his relationship with the universe, maintained it in Genesis 1 and 2 in perfect order. Man would not have died. The suns wouldn't have burned out. The galaxies wouldn't have disintegrated. Nothing would have happened. But he maintained it in his personal deal. Just like he created it, he maintained it in a perfect condition up to that time. That was not to be forever, though. Earth, plants, and animals had a perfect environment after the creation, with probably 100 times more species living today, living in a uniform, mild temperature over the whole earth during Genesis 1 and 2. Lastly, the celestial bodies were visible immediately after the creation because the speed of light is nearly infinite in deep space. Well, I appreciate you being here. We'll go on in the next session, and we'll see that this perfect world that was created in Genesis 1 and 2 was not meant to be forever.